Welcome to this second video in this mini series about making ambient sounds like I did for my album BINAURAL. I already did a long intro for the first video in this series, so I will not repeat myself. In that first video, I explored techniques to make rain and wind sounds. This video will be about machine noises, beeps, bleeps, running motors, steam vents, like more industrial type of things. I will show you a few techniques using the regular system, but I also explored making those types of sounds with the smaller system. I have a few Nokia Circuits modules that I just received last week that I promised to feature in a few videos, so I thought it was a good challenge because I really don't know the modules very well yet. And I thought if I'm able to make the type of sounds I want to make with modules that I just received, then you will probably be able to make those noises with your system as well. And I think it's a nice way to demonstrate how I stumble along for these types of patches. The album BINAURAL is still for download on Bandcamp, and it will probably be forever, or maybe until Solar Maximum hits next year. So if you're into soundscapes, forest, trees, birds, factories, space stations, that kind of thing, please give it a listen. But let's kick off the video with some steam vents. To make a convincing steam vent like you hear in sci-fi movies and maybe movies about submarines, I don't know, large spaceships, factories, etc. In those kinds of places, at least in movies, there's always something going psh in the distance. For that type of sound, I think it's very clear that we first of all need some noise. And since I've started off at the bottom of my case here, I'll try and use Orbit 3 as a noise source. It can be quite harsh. Let's give it a listen. I don't have a regular filter here within the screen, but let's use Enhance 2 here as a filter. You should be able to tame those high frequencies just a little bit. Let's change out this long cable for a short one. So there we have it. To make the steam vent happening, I want to stack two ADSR envelopes. You could just use a gate and an envelope for the effect that I want to achieve. But I will use two ADSRs first, and then I'll demonstrate this with mats. To get this to work, I also need a gate for whenever the imaginary steam vent opens, so let's use manual gate here. Let's disconnect the noise and send it through. Just a regular VCA is okay. The Multimix is a 4-quadrant multiplier, but it doesn't really matter for this type of patch. Let's use mix mode here as a mixer. Currently there's nothing going in, but let's connect the regular output of the first ADSR here Let's flick this to mix. And then when I press the gate, you can see that the VCA opens and we already have some kind of steam vent going on. Now I want to add a second short decay envelope to the start of the sound, simply because, well, those vents release pressure, and the pressure right at the start of the sound, well, I think it's going to be higher. There's always a little bit more energy to the start of the sound, which causes this psh at the start of it. So to mimic that, I'll just use a really short decay. The benefit of using dual ADSR is that the second ADSR is triggered by the gate of the first one as well. So I don't need to mult this gate. But let's just send its output into the mixer as well. Let's turn down the gate. So this is just using this bottom envelope to open and close the VCA. And then if we bring back in the regular gate, to me this sounds a lot more convincing. You could add some tail to this sound. If you don't have a reverb, this is a nice way to like make a mock reverb. So there we have it, steam vent number 1. Let's try the same thing with mats. I'll send the gate into the regular first output there. On mats I do have to mult my gate because there's no normalization. So I'm using the first channel here as a function, a slew generator. I'm using the signal input, and on the second one I'm using the trigger input. And then we can just use the sum output here. Let's close down these static voltages. And let's just see where the settings on mats bring us right now. Well, that's not very good. Let's open up this attenuverter. So there is some attack and decay slew going on. For this first envelope, let's turn this one down and let's listen to the right version, or the right envelope that's getting triggered here. If we turn down the attack, we get this short burst. Maybe make it more exponential. I think that will be nice to mix in with the first channel here. And as you can hear, we have a similar result. You can play around with the timings of these, of course. And you could start multing your envelope shape to your filter. All of this will, of course, contribute to, well, variation in your patch. Let's have a look at how I would do it on this smaller system. For the steam vent, we will, of course, need some noise. I'm just using the noise output from a micro DCO by Soundforce. Any noise will do. And essentially, what you just could do is send your noise through a VCA. Let's take this hex mix VCA here. Patch like a square LFO as CV source, and then when you listen to the output, you will have this periodic opening of the imaginary steam vent. At this point, of course, we're just opening our VCA with a square shape. And just as before, I want to add a little bit of extra energy right to the start of the sound, because usually that's how those steam vents seem to work, probably because of the buildup of the pressure. To do this in this system, I'll just send a melted output of the square LFO to the trigger input of cadence here, which is a triple decay envelope. And then I would like to mix the square LFO. Of course, you could use a random gate, should you have one in your system. I'll be using the hex mix VCA as a mixer as well. These bottom channels don't affect anything that's going on top here. Let's see what we have here. There you can see it, probably just barely on the scope, but there's this envelope shape at the start of it. There we have it. So if I now use that signal to open and close the VCA for our noise nose. We're not opening the VCA for the nose, but this should give us a much more realistic sound. You can send your noise through, I'm punching my camera here, you can send your noise through a filter. Let's use the bandpass output on this root locus here. And depending on the size of your imaginary steam pipe or exhaust vent, whatever, you can start filtering your noise. To make like the motor sound that's starting up, like tuk 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 tuk, that type of thing, I used a looping envelope that was gating some noise through a VCA. Let's use control 1 as a CV source, and yes, let's use mix 3 as a VCA. I'm just going to send through some pink noise from a Maleco noise module. And let's listen to this for a moment. Let's send this through the oscilloscope as well. And then when I open this up, we should start hearing the beginning point of this patch. Maybe something like that. And you could make this really, really simple by just sending an attenuated LFO to your decay rate. I think that's already really nice. Now if I use this same envelope output here to trigger or ping, for example, a filter, let's use filter 8 for that. Let's just send this sound through to your right ear. You should not mix this in stereo, but I just want to show you this without taking up too much of your time. So if you put the filter on the verge of self-oscillation, there. Again, you should not mix this in stereo, but if you want, you can. I think this might sound better when tuned down low. And instead of just using LFO to modulate the length of your looping envelope, I think what I did in my tattoo steel mill patch was use. I realize this is off screen, but I just want to demonstrate this. So I'm just taking an output from dual ADSR, which is an ADSR envelope that actually stays open as long as the gate that you're sending in stays open, and then it starts going down back again. So if I use select 2 here as a makeshift gate source, and I open up the attack and the decay on my envelope, you should hear that as long as the output of select 2 is high, we have the fast turning of the motor, and then when I turn the gate down, because I slewed this gate through an ADSR, it slowly slows down. Let's try it again with a little bit slower of an ADSR. Let's bring up the gate again. You can see the envelope going up. And as long as this signal, which I'm using as a gate, stays high, the motor will be running fast, and then when I turn this down, and of course you can play around with all the tunings and the filtering of these sounds to make it more convincing. What I did was mix it in the back of the mix, so lower volume, a bit of a high cut and a lot of reverb. Let's have a look how we can create the running machine sound in this smaller system. I'll once again start off with some noise going through a VCA. So let's just take the noise output from the micro DCO again, send it through the top channel of the Hexmix VCA, and then let's unplug this for a minute. We could approach this several ways. Let's use Cadence as our envelope. The cool thing with Cadence is that you can link these 3 envelopes. Switching these switches in the up position causes the end of decay gate of the previous decay section to trigger the next one. And if I then take one of these outs here and use that to control the level of the noise with the VCA, we should be able to start hearing where we are going with this. Now, to modulate the decay CV, I will use a looping envelope from delta V. That way I have a little bit control over the level of the envelope. So this is already looping. Let's connect this to the decay CV of cadence. So when delta V is at the lowest position, we have the shortest envelope for cadence. So I should make this shorter here as well. Yes, that was exactly what we were going for. It would be nice to add like another sound to it. And for that we can use a pinged root locus. Let's just take maybe the trigger output at the end of the decay section here to ping our filter. This will of course mean that the pinged filter will not sound at the exact same time as the envelope is happening for the noise, but I think this might be interesting anyway. Let's connect the output of root locus to the mixer here. That might be interesting. Maybe we should tune this down. Yes, that's more like it. And then we can additionally modulate the pitch of root locus with the same envelope to create a little bit more variation. This is the CV input for the frequency. Let's add some FM to this. Maybe if we invert the signal here. Yes, I like that a lot. Of course, we need some reverb, so let's just use Solist here to mix these two sounds in mono. So I can send a custom mix to my Pico DSP here. It doesn't have the greatest reverb, but it certainly is useful, especially for its size. The reason I'm sending it through a submixer first is because when I would send these unattenuated through the reverb, I would overload it pretty quickly. And again, you can filter the noise before sending it to your VCA. Probably should turn this down. You can get all kinds of variations out of this. creating some beepy noises like trucks backing up or just little sub-circuits in, I don't know, a space station activating and doing like beep, beep, beep. Well, it should be pretty straightforward. Even in this smaller system, we just need a square wave LFO to open and close a VCA where we send a really high-pitched sine or triangle through. Well, you can go with a saw wave or a square wave. I like to use the sine wave because it's a little bit less harsh on the ears. And if you want to control this sound so it's not always on, you can send the square LFO through its own VCA. And if you then, for example, take another square LFO that's running slower and use that to let the other one through, then you get something like this. We can start going haywire here with the logic outputs of Obsidian. Let's just try something here. And because we have this chaining feature here, where we can chain the trigger input of the next envelope to the end of decay trigger of the previous one, we can create like these timed events. Let's use this end of decay output to ping a filter. And then we should be able to ping muzzle as well here, which is also a filter, but it's factoral based. It's something weird. Let's just try it. Let's send in some noise here. And then maybe we can send this through, well, through a filter here, just so we can tame the high frequencies a little bit. I think you'll hear that we start getting interesting behaviors here. Maybe let's send the minimum output. I don't know what it's doing actually, or the difference output here. What's the minimum output doing? That kind of follows. Well, let's just use this third envelope here to ping yet another filter. Let's take the input there and then the output here. Maybe I should take the trigger output and like make the decay really long. Yes, I like that. Let's change up the tuning here. And maybe play around with the rates and obsidian here. Let's introduce some cross modulation. Now this sounds nothing like machines anymore when I start introducing cross modulation. I think that's better for organic type sounds. And of course, instead of using square LFOs to trigger this event, you can use a manual gate or something like maybe a chaotic output of some module. I think you get the idea. This is going to be it for this video. I think I'll make a third video in this mini series where I show you how I would make birds, crickets, that type of thing. Maybe even water if I figure out how to do it realistically. In any case, thank you very much for watching. See you next time. Bye.